I'm going to go through a couple of examples for you from the book, just so you've got a few things to refer to. First one I'm going to do is from 7a 1 to a. This is 4x plus 9 equals 21. Now we're asked to solve for x. So what number, x times by 4, add 9 equals 21? You might be able to do that in your head, but there's a method we can follow to do this. We're going to apply some inverse operations to get rid of these numbers around the x. The first number we're going to get rid of is this plus 9. So one way we can get rid of that is to simply take away 9. So we get 4x plus 9, then we take away 9, equals 21. And now when we do something to one side of an equation, we have to do the exact same thing to the other side of the equation. So we now have a new equation. We have 4x plus 9 minus 9 equals 21 minus 9. By putting these minus 9s in there, what we're doing is called applying inverse operations. Our operation was to plus 9. Our inverse operation is to minus 9. What this effectively does is we have plus 9 minus 9, and that equals 0. So what we then end up with is just 4x on this side of the equation. So I'm going to write that on a new line. 4x, the 9's gone, equals, now 21 minus 9, we can evaluate that. 21 minus 9 is 12. So what we did just there was apply the inverse operation of subtracting 9, because we had an add 9. What we now have is 4 times x equals 12. To get rid of this 4, we can apply another inverse operation to this whole equation. The inverse of timesing by 4 is dividing by 4. So let's write this out. Let's go 4x, then our inverse operation is to divide by 4, equals 12, and then we do it to both sides of the equation. We also divide that by 4. So this 4 and 4 here will cancel out, because we have 4 times x, and then we divide it by 4. So if we times something by 4, we can undo it by dividing it by 4. 4 and 4 cancel out. All we are left with there is x. Those 4's are cancelled. Now this side we have 12 over 4. So we've now worked out that x equals 12 fourths, or 12 quarters. We can evaluate that further and go 12 divided by 4 equals 3. So there's your answer, 3. We've worked that out by applying inverse operations, where our first inverse operation here was minus 9, and then our second inverse operation was to divide by 4. Remembering that whatever we do to one side of the equation, we do to the other side of the equation. Let's try a different one. Let's look at 7a 1, 1b. This is 6x equals 42. Now this is a one-step equation. Let's look at what's happened to the x here. We've timesed it by 6. So we want to undo that timesing by 6. Our operation is times 6. So therefore our inverse operation will be to divide by 6. I'm going to write this out very thoroughly. Times 6, our inverse is to divide by 6. So Our rule is, whatever we do to one side of the equation, we do to the other side of the equation. So I'm going to divide this side by 6. Then I'm going to divide this side by 6. These 6's cancel out because we have 6 times something and then we divide it by 6, and that undoes it. And 42 divided by 6 equals 12. There's your answer. Now, another one people seem to have trouble with, because it looks a little different, is where a fraction is popped in. Let's look at 7a 1 3 b. The question here is 1/3 x equals 9. So 1/3 x is equal to 9. So remembering, we want to get this x here all by itself. We have this 1/3 here. Now we can rewrite 1/3 x simply as x divided by 3. Remember that. If you have fraction times by x, you can times that 1 by the x. 1 times x is x over 3 equals 9. So the operation we have here on the x is a divide by 3. That's what this means. Our inverse operation will be to times by 3. Now remember our rule. Anything we do to one side of the equation, we do to the other. So we have x over 3. Apply our inverse operation. Equals 9. Inverse operation is applied to both sides, times by 3. And now what we have here is 3x over 3. 3x over 3. Times those top ones together. Equals 9 times 3. 27. Then we can cancel this 3 out here, because we have 3 times something, then divide by 3, and we're left with x equals 27. Just to make something clear here, if I have these fractions can become confusing. If I have 1/2 x, if I see it written like that, 1/2 x, this means 1/2 times by x. This is the same as x over 2. If I have 1/3 x, this is the same as x over 3. If I have 1/4 x, this is the same as x over 4. We can go on forever. I could have x over 50, 1 times x, 1 over 50 times x equals x over 50. So there's that. Now, I'm just going to do something else. Instead, I'm going to have 2/3, 2 over 3 times by x. This is the same as 2x over 3. If I have 3/4 x, that is the same as 3x over 4. So you see, everywhere here, this bottom line stayed the same. There's a 3 and a 3, 4 and a 4, except the x is there. So it's like we're timing the x by this top number. So here, 3 and 3 stayed the same. We times this x by this top number.